All right, the next characteristics that we're going to look at are the increasing and decreasing intervals. So the increasing interval is described as the x values that make the function go up. And whenever we're talking about the function, I'm going to put quotes around that. Whenever we're talking about the function in math, the function is always written as y equals, and then you have an equation there. So whenever they talk about the function, they actually mean the y coordinate, so aka the y value. So the increasing interval are the x values that make the y value go up. And what this looks like on the graph is it's where the graph slants up to the right. The decreasing interval is the x values that make the function go down. And again, when we say the function, we mean the y values. And this is where the graph slants down to the right. So, if we look at the pictures that we have of our graphs, here's our pictures. We're going to go ahead and label the pictures as increasing or decreasing. So some students have a hard time thinking about it. So what I usually do is I just draw a stick figure there. And I just think about whether the stick figure is going uphill or downhill. So this stick figure, first if he starts walking, this is going to be increasing. And then he hits the vertex and then he goes the other direction. And he starts decreasing. So we know that the increasing interval are the x values that make you increase and the x values that make you decrease. So we want to see what the x value is right here. We want to see what the x value is right here. And we want to see what the x value is right here. And that's going to help us write down what our increasing and decreasing intervals are. So for increasing, the x value right here, it has an arrow that goes to the left. So if we think about this arrow, this graph going to the left forever, 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 we're going to say that this x value right here is negative infinity. This x value over here is going to be positive infinity because that arrow goes to the right forever. And that's always going to be the case when you do these graphs. That a left arrow means negative infinity, a right arrow means positive infinity when we're looking at that. So from left to right. And then my x value right here at the vertex is 4. So I can see that the graph was increasing from negative infinity up to 4. And when we put the 4, we're going to put a parenthesis around that, and I'm going to tell you why in a minute. And then this graph is decreasing from 4 down to infinity. Or I guess I should say all the way over to infinity because that's an x value. So we're going to the right. We're not thinking about up and down here. So it slanted up to the right where it's increasing from negative infinity to 4. It slants down to the right where it's decreasing from the x values of 4 to infinity. Now the reason that we put a parenthesis around the 4 is because if you cover up everything except for the graph and you just look at the 4 and someone asks you, is that part of the graph increasing or decreasing, you would probably say neither because it's just a dot. A dot doesn't slant up to the right, it doesn't slant down to the right, a dot is just a dot. Brackets mean that that number is included in your answer. Parentheses mean that you kind of ignore that number. So I can, if I cover up the 4, I can clearly see that all these numbers are slanting up and all those numbers are slanting down. So those numbers are included. But if I look at just the 4, I can't tell which way it's slanting, and that's why I put a parenthesis there. All right, we're going to do the same over here. So if you look at this graph, my stick figure is right here this time. So if we look at this picture, we can see that he is decreasing first, and then he hits this part right here, and then he starts increasing. And we're going to do the same thing where we're going to label all those x values. So we have an x value right here to label, and right here, and right there. So this x value is a left arrow. Left arrows are always negative infinity. This right arrow is positive infinity. And then this number in between, where it switches directions from going down to going up, is a value, again, of 4. It will not always be 4, but in these two it happens to be the same. So I'm going to say for this one, the increasing interval is from 4 to infinity. Those are x values, 4 to infinity. And the decreasing interval is from negative infinity over to 4. Again, we are not including the 4. We're leaving parentheses around this because if I covered up everything on the graph and just looked at that point, I can't tell if it's slanting up or down. Over here, if I ignore the 4 and look at all the rest of the numbers, it's very clear which way they're slanting. Okay, we also want to look at what the vertex is. So here, I can see the vertex is where the graph switches from increasing to decreasing. So where, I meant to write where. Or vice versa, because it could be from decreasing to increasing. So basically, the vertex is where the graph switches directions. We often see this as the middle of the graph. Or some people see it as the starting point. Oftentimes when people draw an absolute value graph or when they draw a parabola, you'll see them drawing the vertex first. Some graphs don't have a vertex, they don't switch directions, but there is a point that seems similar in nature, and we're not going to go over that for this unit, but we'll see those soon. And we can call this the locator point, so that will come up more later. So the vertex or the locator point, they're actually found in the equation, and they're found using the letters h and k. And when you write the location of the locator point or the vertex, it's going to be the point hk. So when we're using absolute value graphs, we had y equals a times x minus h plus k. So the vertex from that would be the opposite of this number, the opposite of that number, and then this number exactly. So h and k. So if we look at our pictures, you can see the vertex in two different ways. You can see it from the equation, or you can see it from the graph itself. So if I look at the graph itself, I can see the vertex is at the point 4, -1. If I look at the equation, I can see I've got the opposite of this number. So the opposite of -4 is +4, and then this number on the end exactly. So 4, -1. If I look at the other picture, again, I have a vertex with an x-coordinate of 4. And then this time the y-coordinate of the vertex is -3. And again, we can see those in the equation itself. So the opposite of that number, and then this number exactly.